Hello guys, welcome in today's session. I am Professor Fayyaz Karadi from Department of Mechanical Engineering. With continuation with today's session, today we are going to discuss how to draw the displacement diagram when the follower motion is uniform acceleration and retardation and cycloidal. This is our part 2 with continuation with today's session from unit number 4, cam and follower from theory of machine subject. For drawing the displacement diagram, I am taking one problem statement which is in front of you. A cam drives a flat reciprocating follower in the following manner. During first 120-degree rotation of cam, the follower moves outward through a distance of 20 mm with uniform acceleration and retardation. The follower dwells during next 30 degree of cam rotation, and during next 120 degree of cam rotation, the follower moves inward with uniform acceleration and retardation. The follower dwells for the next 90 degree of cam rotation. So in forward stroke, which is given here outward stroke, or rise of the follower, uniform acceleration retardation motion it have, and at the same time during return stroke, it is having the same uniform and acceleration and retardation. That means in forward and in reverse stroke, the follow motion is same, that is uniform acceleration and retardation. So this is general sketch after completion of displacement diagram, which you can see in front of you. In forward stroke, again this is uniform acceleration retardation motion, and in return stroke also the follow motion is uniform acceleration retardation. Here the theta O is written here, that is theta for outward stroke. Second, theta for a dwell period, that is theta for a return stroke, and again theta for dwell period, which is given in the problem statement. Theta outward is given 120 degree and theta dwell is given 30 degree. For next again 120 degree, that is theta return stroke, and for next it is dwell period, which is given 90 degree. So theta dwell here come in 90 degree. So this is general figure after completion of displacement diagram. So let us see one by one how to draw this curve in forward stroke only. I will explain in forward stroke, and you can understand, you can draw for a return stroke also by following the same procedure. Okay. Now, as a regular, on x-axis, I will plot the angle of rotation of cam, that is nothing but angle of ascent or a rise of the follower. And on y-axis, I will plot maximum follower lift, which is given in problem statement, that is 20 mm. 20 mm. And on x-axis, I will plot angle of rotation. For converting that degree in linear displacement, I will take the suitable scale here, which is 10 degree is equal to 1 centimeter is nothing but 10 mm. That means 10 degree is equal to 10 mm. In engineering, all dimensions will be in mm. So 10 degree is equal to 10 mm, which you have to write in your answer sheet also. Okay. So as per given data, this angle of ascent or a rise angle of the follower is given 120 degrees. So I will draw the line AX as 12 centimeter or 120 mm. And on y-axis AU, I will draw 20 mm, which is given in problem statement as 20 mm. Follower moves outward through a distance of 20 mm. That 20 mm I will plot on vertical axis or on y-axis. This distance will be 20 mm and this distance will be 12 centimeter or 120 mm. This 120 mm, as per our regular procedure, I will divide into number of even parts. So this 120 I will divide into 6 number of equal parts. So one part will be of 20 mm. 20 mm into 6, that will be 120 mm. Okay, so I will divide that AX into 6 number of equal parts. You can divide into 8 number of equal parts also. Okay, so and so next step is from all these points, through all these points, I will draw the line perpendicular to the follower lift. So from 1, 2, 3, 4, 5 and 6, I will draw the perpendicular straight line. Okay, now I will divide that into this. I will highlight it by a red color. Why? Because this 1, 2, 3, that much part will be given for acceleration, and that much part will be given part number 4, 5 and 6. That much distance is given for a retardation. So up to A to 3, that length is given for acceleration, and from 3 to 6, that length is given for a retardation. That's why I draw the line in a red color, because uniform acceleration and retardation is given. So uniform distance is distributed from A to 6. So midpoint is I draw by a red color. Okay, now next step is this red color line, this mid line, I will divide into same number of equal part as that I divide into number of equal parts. Here this x axis I will divide into 6 number of equal parts. So this vertical line also I will divide into 6 number of equal parts and give the numbers from bottom to top. Why? Because the follower is moving from in outward slope from bottom to top. So this is first, second, third, fourth, fifth and sixth part of this vertical line. Okay, now how to join this line? The next part is joining of the line from the bottom point A, bottom left point A. I will draw the construction line from, I will join A to 1, second A to 2 and third A to 3. This I will join by a dotted line or straight line, as it is a construction line. It is not a actual curve. And next step is from G point, from top right corner, I will join G to 4, G to 5 and G to 6 like this. Okay. Understand clearly the procedure, how I am joining the lines. A1, A2, A3 form middle center line, which I shown by a red line. Okay, now next G4, G5 and G6. This I will join by construction line. Now how to get the intersection point to draw the curve? This is our next step. Now I will take the intersection point from one vertical line and A1, this inclined line. Where it intersects, that will be my first intersection point, and that point is denoted by B. This is my 0, 0 point. Okay. Now B point is the intersection of this one vertical line and this one inclined line. Okay. Now next C point, this will be intersection point of these two vertical line and these two inclined line. Same wise, this D point will be intersection of these three vertical line and these three inclined line. Likewise, A, B, C, D, I got the point here. You can see here A, B, C, D. How that point is getting, that you have to clearly understand. This B point is the intersection of this one vertical line and this one inclined line. C point is the intersection point that I am getting here from this vertical 2 line and inclined 2 line. This D point is the intersection of this vertical 3 line and inclined 3 line. Same wise, I will get the point is here also. The next point will be intersection of these 4 and these 4. Next intersection point is this inclined line 5 and this vertical line 5. And last intersection point will be this vertical line 6 and this horizontal line 6, which is nothing but G point. Okay. Now you can see here E, F, G. How I get this point? By intersection of. So understand the procedure how to get the intersection point clearly. Okay. A, B, C, D, E, F, G. These 6 points I will get from intersection of these 6 lines. Okay. Now these points A, B, C, D, E, F, G I will join by a smooth curve. A to B, B to C, C to D, D to E, E to F, and F to G I will join by smooth curve. This is my displacement curve when the follower is uniform acceleration and retardation motion. This part is acceleration part and this part is retardation, and both the curve is symmetrical. Why? Because we are giving the same uniform distance for uniform acceleration also and retardation also. The same procedure you will follow for outward stroke also. The same procedure you will follow for outward stroke by reverse only, reversing the procedure. Now I will give the numbers here 1, 2, 3, 4, 5, 6, and for outward stroke you can change the number like this: 6, 5, 4, 3, 2, 1, 0. Like we also you can change the number for reverse procedure. And how to do the numbers in this vertical line? By reverse procedure from top to bottom. Here I will give the number from bottom to top. Why? Because the follower is moving from bottom to top, and in reverse stroke the follower is moving from top to bottom. So I will give the numbers here: 6, 5, 4, 3, 2, 1, 0. Biologically also you can give the numbers here and you will get the curve here. The intersection of point this and intersection of point this will be this point J. K point is the intersection of 2 and D dash here. Third L point is the intersection of this and this last line here. And next intersection point M is intersection of B and this 4, or this 4 and this 4. Okay. Likewise, you will get the different point J, K, L, M, N, and these points you will join by smooth curve when the motion of the follower is uniform acceleration retardation for a return stroke also. Now come to the last motion of the follower, which is a cycloidal motion. Again, I am writing here problem statement. The cam drives a flat reciprocating follower in the following manner. During first 120-degree rotation of the cam, the follower moves outward with cycloidal through a distance of 40 mm. That means this vertical, which I will plot on y-axis, that distance will be 40 mm, which is follower rise. Okay, the follower dwell during next 30 degree of cam rotation. During next 120 degree of cam rotation, the follower moves inward with cycloidal. The follower dwells for the next 90 degree of cam rotation. That is the data which is given in problem statement. Now see how to draw the displacement curve when the follower motion is cycloidal. Again, as earlier, on x-axis I will draw the rotation of cam, and on y-axis I will plot the follower lift by taking a suitable scale. Now again I will divide the rotation of cam into number of equal parts, that is 6. Okay, and I will give the numbers here: 1, 2, 3, 4, 5, 6. The next procedure is same as earlier. From all the points I will draw the vertical lines from all the points through 1, 2, 3, 4, 5, 6. I will draw the vertical line. Now here the procedure is changed as earlier. What is the special difference in this? Now I will, through point A, I will draw the circle. Through point A, I will draw the circle. So to drawing the circle, what will be the radius of that circle and how much distance I have to take in the compass while drawing the circle? Now see this, the to find out the radius of this circle, I am taking that formula S is equal to 2 pi r, which is nothing but circumference of this circle, 2 pi r or pi into d. So what is that S distance? S is nothing but lift of the follower. Whatever distance is given in the problem statement, that I have to take as S. So in this problem statement, that S which I have plot on y-axis, that is given as 40 mm. So I will put that 40 mm in place of S, that is nothing but a displacement of follower or rise of the follower or lift of the follower, which is given 40 mm is equal to 2 pi r. So we have to find out the value of r. So putting the values, I will find the value of r is equal to 6.36 mm. That distance you have to keep in compass. Okay, 6.36 or 6.5, and by taking that much distance, A as a center, I will draw the circle here. Remember this, whatever distance or lift of the follower is given, that will be S, and that S you will put here in this problem statement, that S is given 40 mm. So value of R is equal to 6.36. Okay, this S is equal to circumference of this circle, which is nothing but, what is the formula for circumference? 2 pi r or pi d. So value of r will become here 6.36. Clear that point? Now after drawing the circle here, the next step is divide that circle into whatever parts you will divide the linear displacement, the same you have to divide the circle also. If you divide that line into 6 number of equal parts, you will divide the circle into 6 number of equal parts. If you divide that line into 8 number of equal parts, divide that circle into 8 number of equal parts. Okay, this I will divide into 6 number of equal parts. So I will divide that circle into 6 number of equal parts and give the numbers in clockwise direction. So this will be 0 and this first part will be number 1. So first part will be of 60 degree, 60 degree, next 60 degree and next 60 degree. So each part will be of 60 degree. So this complete circle will be of 360 degree. And give the numbers like this: 1, 2, 3, 4, 5, 6. Don't be confused by looking at this figure and actually you will draw whatever you will draw on the drawing sheet. Don't be confused in that. Okay, now after that I will join A1, A2 like this. A1, A2, A3, A4, A5, A6. Or you can directly join 1 to 2, 3 to 6, 4 to 5. The second method is that you can join A1, A2, A3, A4, A5 and A6, and after that you will project that one point on this vertical line of that circle. Project that 2 point on the vertical line. Project that 3 point on that vertical line. Project that 4 point on the vertical line. Okay. 1 point you will project on the vertical line and give the name as small a. 2 project on that vertical line and that point will be same, so name will be same as small a. Project that 3 point on that vertical line AU and give the name as capital A, which is same. 4 project on that vertical line and give the name as B. 5 project on that vertical line, which is the same point as B, and 6 project on the vertical line, this vertical line, and this will coincide the previous A point. Okay. Now next point is join line A to G. Join line A to G. Here you can see that in faint red color. Join AG, which is again you can say the diagonal of this rectangle also. Diagonal of this rectangle AG. It is not necessary to coincide that A phi with AG. It is not necessary. Okay, and don't be confused in that. Now next point, after drawing AG, draw parallel line to AG from this small point A and this small through small b, which is parallel to both the line. Okay, now see here, through that point AG, through the line AG, I will draw the parallel line through the small a and through point small b. Okay, I repeat again. Through line AG, I will draw parallel line with help of roller scale through point small a, and I will draw parallel line to AG through point small b. You can see here 3 lines. Okay, now the next step is to get the intersection point now, which is most important point. Okay, A is the first point, B is intersection of this one vertical line and this first vertical line, first inclined line. One is that point. I will project that point on this vertical line and that point will be A, and through that point I will get the intersection point B. That means B point is the intersection of this one vertical line and projection of this one on the horizontal line, on the vertical line, and this inclined line. Okay, now C is the second point through these two vertical line and these two line which I will project on this vertical line, which is point A, and through that through that inclined line. Okay. 3 is the point where through that third vertical line and this third point which is project on this vertical straight line. This point will be A, and this inclination will be, this will be third intersection point. Fourth intersection point will be this fourth vertical line, and this fourth point which I will project on this vertical line, that point will be small p, and this small b will be project on here. This will be fourth point. Fifth point will be fifth vertical line, and this point I will project on this vertical line, which is again a B point, and through this B point I will draw the straight parallel line, and this will be the intersection point. And last one is this sixth straight vertical line and this sixth point which I will project on vertical line, which is A point, and this will be a last point, intersection point at G. So I will get the different point A, B, C, D, E, F, and G. This I will join by a smooth curve. Okay, so this is the procedure to draw the displacement curve when the follower motion is cycloidal. So for all 4 different follower motion, the procedure to draw the displacement curve is different, and that you have to remember the procedure while drawing the displacement curve in the examination, and you have to clearly read the problem statement carefully in which follower motion is given in forward stroke and in return stroke. At that time you have to draw the different accordingly the different displacement curve. Okay, so I will show some different combination of the follower motion which is given in forward stroke and in a return stroke, or during rise and return stroke. Okay, any combination will be asked in the examination. In this is the outward stroke or rise of the follower or forward stroke. Okay, this procedure is when the follower motion is cycloidal. This curve which is get here, this curve is showing that this is a cycloidal motion during forward stroke. And this procedure, by this procedure, the outward stroke is drawn, outward curve is drawn. This procedure shows when the follower motion is uniform acceleration and retardation. Okay, so forward motion is cycloidal and return motion of the follower is uniform acceleration and retardation. In this problem statement, the forward motion or outward stroke or rise of the follower is cycloidal motion and the return stroke is uniform velocity or uniform motion. Okay. In this, the forward motion is simple harmonic motion. So you will follow this procedure to draw the displacement curve. And in return stroke, that is uniform motion. And in next problem statement, you can see in forward stroke, the simple harmonic motion is given, and in return stroke, uniform acceleration and retardation motion is given. So any combination will be given in the examination. You have to read the problem statement carefully, and according to the given data, you have to draw the displacement diagram. Because if your displacement diagram will be wrong, your cam profile will be wrong. Okay, because the same dimension we are using for drawing the cam profile, the same dimension, the same figure we are using for drawing the cam profile. So don't make mistake by drawing the cam profile as per the given data in problem statement. So this is all about how to draw the displacement diagram for given follower motion. So at the end of this session, the student can be able to draw the displacement diagram for uniform acceleration, retardation, and cycloidal motion of the follower. So thank you so much for watching this video.